Well, welcome back, DLs. Okay, good to see you. Uh, Giselle and Lacey, at least. Good to see you. Um, Lacey, hope you're enjoying your vacation. Okay, let's have a word of prayer and we'll get started. I'm going to be sitting down today. I am extremely exhausted. Shh, time to be quiet. Shh. Anybody want to pray today? Oh, come on. Thank you, Ricky. Okay, quiet. Thank you. Okay, um, DLs, I understand that yesterday in Bible class. So if you've looked at that recording, evidently I cut you short because what happened was that the screen on the computer froze, and so I was updating you, trying to get that going, and when I clicked off of my teacher screen selection and tried to get your screen back in motion, that cut the stream. And so I apologize for that. So if there is, not sure exactly how far we got or how far where we started, but here's what I'll do for you. Let me just click out of this. It'd be easier to do it this way. And some of you that were absent yesterday, I don't know what you caught. Did you go on stream yesterday? Jaden, did you get it yesterday? Okay. Let me click out and go back. Didn't cover that much, but we did cover some things. So if you got this, bear with us. If you didn't, I'm going to go through it all again, just quickly to get you the answers that you need. Okay. Because we're not that far into it, so it shouldn't be that hard. So your first verse was, let me put my clicker in. And the way we go, Proverbs 14:29. This was like on what, page 190, right? 205. Wow, I'm always behind. Okay, 205. Okay. So we are at Proverbs 14:29. That was the first one, and the answer to that was slow to wrath, anger. Yep. Actually, that's a good thought. Actually, right now would be a good time because we're just updating. So, I'm in here a little bit. Okay. Second verse, 24:10, and the answer to that is one whose strength is small. We got through all these verses, so that's where we left off. Next verse. You ready? You ready? Okay. 24:16. And the answer to that would be keep trying to succeed regardless of the times we fall. Or he falls. However you want to look at. He be talking about the man in the verse. 204 and 5. Okay, ready? Next verse is 15:18. And in this verse, the word appeaseth means to bring to state of peace, quiet, ease, calm, contentment, to pacify, to soothe. Answer to that would be he would appease him. Okay, next verse, 15:28. And the answer to that, he thinks before answering. Okay, next verse, 24:21. Answer to that is one who is given to change, one who doesn't fear God or authorities. Looks like I'm going to have to proofread a little bit closer. Yeah, volleyball, when you're done with your verse quiz, you can turn them in if you want to while we're doing this. Okay. Or just put them in the box there. Thank you. Okay, next verse, 25:15. And the answer to that is patiently and with a soft tongue. Yes, right now you can. Okay? Ready? Next verse. 14:26, and the answer, the fear of the Lord. Okay? Next verse. 16:32, and the answer, better than the mighty, or he that captures a city. How strong a long-suffering man is. Okay? Next verse. 15:28. Under the category, how weak a man who cannot control his temper is. Answer, like a broken down city without walls. Make sure you're off your phones right now. Let's worry about ourselves right now, please. Adrian, worry about yourself right now. She's been told, just like you've been told. If she wants her phone taken away, then we'll oblige her. Okay? Why should you take the laptop away? Okay. Okay. Now, can I continue? Can I continue? Thank you. Can I continue? Thank you. Stop. Okay, next verse. Proverbs 20:22. About the category when he's faced with temptation to seek revenge, what will be the response of the long-suffering person? Not to take a revenge. Wait on the Lord. Okay. And that brings us up to where we are today. Okay? Okay. The further insight into long suffering. Shh. Okay. Got a couple definitions. Okay. Your Hebrew words are arak. Is that how you would pronounce it? To draw out, to strengthen, or to lengthen, to stretch out. Anaf. Close enough? Enough. To breathe hard, to be engaged, to be angry. Now, ladies, quit talking. Both of those words refer to go a long time without showing your rage or anger. Okay? Your Greek words, makrothumia, okay, close enough, I think, for me. A combination of two words that mean long-tempered. The primary application of long-suffering is to the temper. It includes the idea of being able to take suffering, abuse, verbal attacks, and discouragement without quitting or lashing out in anger. Adrian, that's one. So, what's the basis? Well, Christ is our example for long suffering. Okay. 1 Peter 3:20 it says, which were sometimes disobedient, when once the long suffering of God waited in the days of Noah, while the ark was preparing, wherein few, that is, 8 souls were saved by water. Now, when we hear about the story about Noah and the flood, okay, this is one aspect that we overlook. Okay, how long did it take Noah to build the ark? 100-ish years, right? I can't remember the exact number, but 100-ish. Okay, patience of God for 100 years, in our perspective, that's a long time to wait. Long time to be patient, to let people decide whether they want to get on board or not. Okay? And God, I'm assuming, would have let anybody else on board that wanted to. And yet no one took him up on it. Okay? But the patience, that the long suffering, the ridicule that Noah was getting for 100 years, and his sons and his family, okay, had to take a toll in some way, humanly speaking. And yet he got over that, got through that, because he knew that's what God wanted him to do. 2 Peter 3:9 says, the Lord is not slack concerning his promise, as some men count slackness, but is long-suffering to usward, not willing that any should perish, but that all should come to repentance. The long-suffering that God puts with us, with mankind. Giving mankind chance upon chance upon chance upon chance to accept. Pretty soon, there's going to be an end to his long suffering. He's going to say, that's enough. And at that point, there'll be no return or no chance of salvation on those people. That's going to come when the rapture happens. But yet, after that, I believe that still people can get saved through the tribulation. But the great white throne judgment will be the final time when he says no. Today, people, Lord has the power over life and death. And I do believe that the Lord God does allow people's lives to end earlier than what's expected because of what their life is like, because they have rejected God enough, and whatever those circumstances might be, I think God's long suffering comes to an end with those situations too. Question here, how did God show his long suffering in Noah's days? He waited until the ark was built before sending the flood. Okay? Now, that's logically speaking. I mean, why would God send the flood before the ark was done? Okay? I mean, hand in hand, but he waited. He had to wait for it to happen. Okay? Hang on, let me check these out. Okay. Hang on. Okay. In what way is God long-suffering to us? I want you to think about that for just a minute before I put the answer up that I have. In your life, in just maybe yesterday, how is God being long-suffering to you? This is what my book has. Because he doesn't punish us immediately. And because he doesn't want anybody to perish. Because of our sin, we don't... I'm trying to think of how to say this, but God could end our lives at any time. And yet God preserves us because he wants us to change. He wants us, if we're not a child of his, to become a child of his. Gabby? Yes? Okay. Thank you, Gabby. Okay. As you're writing this answer down, put doesn't want any to perish. Okay? Doesn't want, huh? He doesn't want anybody to perish. So however you want to phrase it, okay? So what great blessing is possible to us because he's long suffering? Shh. salvation. That's the ultimate thing. That's our gift. That's our blessing. What then would be the result if God were not long suffering? Shh. We all would be damned to hell. There would be no salvation. Think of how long God's been long suffering with this aspect of salvation from the beginning. Okay, before I go on, remember that tomorrow we have a verse quiz, Proverbs 23, 31, and 32. And next week, a little change in schedule. Special chapel Monday, Wednesday, Thursday, and Friday. Bible class on Tuesday. Okay, let me finish. Once again, special chapel Monday, Wednesday, Thursday, and Friday. Bible class on Tuesday. Now we have the magician ventriloquist. Can't think what his name coming. Okay. He's coming next week. So DLs, I'm sure that you can, whatever you need to do to tune into the chapel. It'll still be at 8:30, and so tune into that again Monday, Wednesday, Thursday, and Friday. Okay, back to Bible class on Tuesday. So I wanted to make sure you guys knew that before we went. And actually, this probably is a good place to stop at this point because we're almost out of time. We'll pick it up on the principle tomorrow or on Tuesday, and we'll see you DLs especially tune back in at science time, and otherwise we'll see you. Have a great day, have a great hour, however you want to say that. Okay.
morning for those of you in distance learning. Glad to see you guys are back online. Just make sure you guys comment that if you're here so that I can mark you present and take out your vocab books. Everybody, come back to your seat. Julia, vocab book. Ricky, vocab book. Aaron, Andrew. Sorry, that's like the third time I've done that. Normally, I call Aaron Andrew because I come from this class to that class, but I don't know why I've been calling you Aaron for the last few classes. Sorry. All right, page 91. Page 91. Let's go ahead and fill in vocab. Go ahead and start doing exercise C, filling in the prefixes, roots, and suffixes. Prefixes, roots, and suffixes. Exercise C. Start working on your exercise. C. Lena, have your quarter change. Sophia, quarter change. Oh boy. All right, who has intro? Class, we should all have that one. Inside within. Verse, class? To turn. And then ION. Raise your hand if you have this one. Andrew? State quality active. Who has the literal meaning? Literal meaning. Jesse? Okay, this one would be the state of it, okay? State of turning within. Really, really close. Good job, okay? Next word, obsequious. Obsequious? Interesting. What is ob, class? Against, toward, completely. And then sequi, to follow. And then OUS, we'd have to look up. Class, what was this one? Having the quality of. Who has the definition? Who has it? Gabby? Having the quality of following completely. Following completely. Okay. Pro. Class, what's pro? What was it? For before forward. Okay. Someone had to look up cess. Raise your hand if you have it. Cess. Okay, I literally just said raise your hand, but yeah, to go, to yield. Gotta listen. ION, who has that one? Raise your hand. Avery. State quality active. And then AL. Derek? Like, pertaining to. Ricky, do you have the literal meaning? Okay, who has the literal meaning? Jaden? Okay, pertaining to the state of going forward. Don't forget the ION. Pertaining to the state of going forward. Okay, tonight for homework, write your prefixes, roots, and suffixes twice. That quiz will be on Tuesday. Okay? For those of you who are leaving for the volleyball team tomorrow, make sure you turn that in today, because obviously we'll be all gone tomorrow. So make sure that's turned in today. Avery, Gabby, for the tournament. The homework for today. Make sure that's turned in my tray today, okay? All right, go ahead and put that away and take out your literature. Take out your literature. Spelling is prefixes, roots, and suffixes twice. Turn to page 297. Page 297. Talking about two ancient Indian fables, okay? Two ancient Indian fables. Let's go ahead and read this together, all right? Who can stand and start reading this out loud for me? Go ahead, Amethyst. This was translated by William Carey. Huh? Possibly. Possibly.
Two ancient Indian fables translated by William Carey. A yogi told a Brahmin that he was on his way to meet God. And tell him, cried the Brahmin, of the wretched poverty of my wife, my son, and myself, and implore his deliverance. Which the yogi promised and did. And God said, if each shall wish immediately after bathing, their desires shall be granted. Upon hearing from the yogi this good news, the wife hasted to bathe and to wish for youth and beauty, rich adornment and raiment. And these were hers by an instant transformation. So fair and fluent she looked that she was coveted by a Mohammedan, who had her seized and set beside him in his carriage. At this calamity, the son ran to his bath and wished that his mother might change into a pig. For then the Mohammedan would spurn and thrust her from beside him, which also came to pass. The Brahmin in anguish bathed and wished, oh, let us be as we were, and thereafter murmured at his poverty no more. A devout Brahmin asked an alms at the house of a cobbler. The cobbler's Maina cried crossly, be off, you hypocrite, you thief! Timid and vexed, the Brahmin moved away. At a sage's he next begged. Come in, man of God, come in, said the sage's Maina. This house is blessed by your presence. The Brahmin told how he had been insulted by the bird of the cobbler. And yet, said the Maina, we are from one nest. Only he has learned to talk like his master, I like mine.
Good, okay? Look at the first Indian fable, okay? A yogi, class, what's a yogi? Teacher of religion told a Brahmin, what is a Brahmin? A Hindu of high position. So if you guys remember that in India there is a caste system. And at the top of the caste system are the Brahmins. They are a Hindu of high positions. They are the high class. Remember, in the caste system, you're not able to get out of your caste. That's what you were born in. You're not able to change it. So a yogi, a teacher of religion, told this high class guy that he was on his way to meet God. Okay, the Brahmin said, tell him of the wretched poverty of my wife, my son, and myself, and implore his deliverance. What was he complaining about, class? Poverty. He was being poor. All right. So what did he wish for? What did they wish for? Okay. Riches. What did the wife wish for? Beauty. Sorry? Beauty and youth, rich adornment and raiment. Obviously, wishing for what kind of things? Eternal or material, class? Material. Okay. So then, obviously, he had a son. Okay. What did his son wish for? Okay. That he turned his mom into a pig. He wished that his mother might change into a pig. For then the Mohammedan would spurn and thrust her from beside him. He basically said, I wish that she was turning into a pig so that he could get rid of the wife. Because remember, this guy, he put his wife next to him in a carriage. The Mohammedan, by a random Mohammedan, so he took the wife, put her beside him, and then the son wished that she would be turned into a pig so that she could leave the Mohammedan. Hello. Yeah. Give me 1 second. I chose orange pineapple juice and Skittles. All right, so basically, obviously, these people, were they happy or unhappy, class? Unhappy, so they wish for something material. What's a lesson that we can learn here? Okay, material things will never make you happy. What else? What else can we learn from this story? Andrew? How to be content. Okay, anybody else want to add to it?
Like how the Bible says, like, put your riches up in heaven, not in earth.
Okay, our riches should be based. Yes. Huh? Okay. So yeah, so the first tale would be paper what? Oh, okay. So the first tale obviously would be to be content with what you have. Riches can always bring you happiness. Okay, true happiness lies within things that are beyond this world, obviously, things that would last forever. Okay? Now, the next Indian tale, okay? A devout Brahmin asked an alms at the house of a cobbler. What's a cobbler, class? We should already know that. Okay, what was it? A cobbler? A shoemaker, okay? He was a shoemaker. Remember, we've already studied or kind of had some stories with the cobbler and the rich man. So a cobbler is a shoemaker. They cried crossly, "Be off, you hypocrite, you thief." Because obviously a Brahmin, he's supposed to be super high class, okay? That's what a Brahmin is. They're the highest caste system. But if the Brahmin is asking for or begging for alms, okay, the cobbler's maina, someone who worked for him, was like, "Be off, you hypocrite, you thief." Timid and vexed, the Brahmin moved away. At a sage's, he next begged. So he went to somebody else and he begged. And then the person actually said, "Come in, man of God, come in." And he welcomed him, the sage's maina. "This house is blessed by your presence." Then the Brahmin told how he had been insulted by the bird of a cobbler. "And yet," said the maina, "we are from one nest. Only he has learned to talk like his master and I like mine." Okay, what do you think that means? He says, this guy was talking like his master and he was rude, and I talk like my master. The sage was talking that to the Brahmin. He was saying he was a man of God. He was welcoming him in. Amethyst?
The Brahmin was kind of basically like the cobbler's master because he was his superior.
Mm-hmm.
So he had learned to talk like that from the Brahmin because they would look down on him.
Mm-hmm.
But the sage had learned how to talk like God. He was his ultimate master. And that's why he was nice.
Good. Okay, so what lesson can we learn from treating, like, and how to treat others, class? What lesson can we learn here? Treat others with kindness, okay? It doesn't matter who they are. They could be the highest of class or the lowest of class, okay? Treat others with kindness, and God will bless you for it, all right? Look at the background, okay? This was translated to ancient Indian fables. William Carey was a missionary to India. If you guys look, he was the father of modern missions. You want to highlight that about him. William Carey was the father of modern missions. He was born in England. Although he received very formal education, or very little formal education, as a boy, he read constantly and taught himself Greek, Latin, French, and Dutch, so he could read the literature of these languages as well as English classics. His early practices in languages aided him greatly in his life's work as a missionary to India, where he mastered the Indian languages in order to win more people to Christ. His motto was, "Attempt great things for God, expect great things from God." Just some things about William Carey. He was the one that translated these two ancient Indian fables. Okay? All right, that concludes unit number 11. Okay? So our test over units 10 and 11 will be on Wednesday. All right? So obviously tomorrow we won't be here. But we need people to make up their quizzes, and then on Monday, I'll give you all the stuff that you need to know for your test. And make sure you guys if you guys want to get ahead, study the authors. Obviously, authors are a huge thing to know, and poetic devices, okay? So authors, poetic devices, and then we'll get on Monday everything you need to know about the plot of the different stories that we've read. All right, go ahead and put that away and take out your grammar books. And then turn to page number 237. 237. So yesterday we talked about adjective clauses. Class, what do clauses have that phrases don't? Yeah. Subject and what class? Verb. Adrian and Isaac. Okay. What do clauses have that phrases don't? We just said it. Not nouns. I'm not talking to you. I'm talking to Adrian. But thank you. What do clauses have? Austin so graciously told you. Subjects and verbs. Okay, make sure you guys are paying attention. All right, otherwise I'm going to move both of you up here. Okay? So clauses, they have subjects and verbs, okay? Nothing different than what we've already studied, okay? But with adjective clauses, give the four relatives that are introducing adjective clauses. Class, it's number 5, okay? Who, whom, which, and that, okay? Who, whom, which, and that we know introduce adjective clauses. These are relative pronouns. Whose and occasionally which are relative adjectives, when and where are relative adverbs, okay, but they still introduce clauses, okay? So let's go ahead. We already did exercise A, bracketing off our clauses. So let's do exercise B. We're doing the same exact thing that we did, circling our relatives, finding our clauses, but now we're finding the word that this adjective clause describes, okay? So exercise B, number 1, okay? Circle each relative. If the relative is a pronoun as understood, supply it and circle it. So remember, yesterday we did one where there was an understood relative there. We had to put the word that above our pronoun or above our adjective clause, but it could still be a dependent clause there. Just make sure that you guys are watching for that, okay? Number 2, put parentheses around the adjective clauses and then draw, number 3, an arrow from the relative to the noun or pronoun that the clause describes or modifies, okay? Number 1, what is my relative here, class? There was a time when Jesus walked on earth among men. Okay, so if it was there, what's my clause there? Okay, so what's my subject and my verb in there? Okay, time was, but in these sentences, guys, okay, is there a relative pronoun? No. Okay, so we know that's not my clause. What's my clause there, class? When. My relative is when. Okay, circle when. Okay. Okay, so what's my entire clause? When Jesus walked on earth among men. Good. Okay, so what is this clause describing? Time. Good. I would draw my arrow back to time. It's saying what time? The time when Jesus walked on earth among men. We know it's an adjective clause because what part of speech is time, class? Part of speech. Part of speech. Noun. Okay? Part of speech is nouns, pronouns, verbs, adjectives, adverbs. We all should know that by now. Okay? Number 2, that will keep him in perfect peace, whose mind is stayed on thee. What's my relative here? Whose. Good. Okay, what's my entire clause? Whose mind is stayed on thee. Who is this talking about? What is this describing? What was the class? Him. Okay? Notice how the word peace comes before it. Don't get confused with that. It's not saying what kind of peace, the peace whose mind is stayed on thee. It's describing him. Which him? The one whose mind is stayed on thee. So you can ask yourself these questions. If it makes sense, then that's what it's describing. Okay, number 3. The film we will see tomorrow is based on a biography of Martin Luther. Are there any relatives that we can see here, class? No, so we know that we might have to add an understood one. Where can we put an understood relative there, Andrew? Before we, okay? So what would you put there? Good, okay? The film that we will see tomorrow, okay? That's my entire clause, and what word is it describing? What was it? Film. Good. Okay, it's saying which film? The film that we will see tomorrow. You guys see how these are describing nouns? Further explaining them. Okay. Number 4. Sorry, Melville Dewey, whose decimal classification we often use for nonfiction books, also founded the first school to train librarians. What's my relative here? Whose? What's my entire clause? Awesome. That entire clause there, that's what you put parentheses around. Okay? Who is this entire clause talking about, class? Melville Dewey. Good. Describing Melville Dewey. Number 5, the word luna, from which we get words like lunar and lunatic, is Latin for moon. Okay? Jaden, what's my relative there? Which. Good. What would I put parentheses around, Ricky? So which we get words like lunar and lunatic is Latin for moon? Just to lunatic. Good. Okay, why? Class, why do we stop at lunatic? What is Latin for moon part of? Is it part of my dependent clause or my independent clause? Independent clause. That's my main verb there. The word luna, word is my subject, is my verb. Okay, so it cannot be part of my dependent clause. My dependent clause, which we get words like lunar and lunatic, describe what word, class? Luna. Good. Number 6, obey them that have the rule over you and submit yourselves. Avery, what's my relative? That. Lena, what's my entire clause? That have the rule over you. Good. Maya, what's it describing? Them. Awesome. Good. Number 7, books are not made for furniture, but there is nothing else that so beautifully furnishes a house. Jesse, looking at that, what's my relative there? What do we just say that there is? Is that a relative? Okay. So any other words that can introduce a clause? That. Awesome. Okay, what's my entire clause there, Isaac? Good. What is that clause describing there, Yuvia? Not house, because house is part of my clause. Your clause can't describe a word that's within the clause. Elijah, do you know what this clause is describing? Not the books. Not the furniture. Class, who knows? Else, okay? Else is a noun, nothing describing the word else. Number 8, battles are won by those who believe in winning. What's my relative here, class? Who? What is my entire clause, Derek? Okay, what's it describing, Doug? Those. Awesome. Number 9, if you always live with those who are lame, you will yourself learn to limp. Okay, what's my relative there? Lena? Who? What's my entire clause there, Austin? No. Yes. We are. Who to what? Yeah, who to what? That's number 10. Okay. Who are lame, you will yourself learn to limp? Good. All the way to lame. Who are lame? You will yourself learn to limp is its own independent clause. Okay. Good. What is that clause describing there? Adrian? Those. Number 10, Machiavelli is the man we studied about today. Class, is there a relative that we can see? No, so we need to put something there. Ricky?
So into humanity that
Okay. With the word that, okay, we learned this in our pronouns. It never describes people. Okay? Actually, yeah, that could work. Okay, sorry about that. Yes, that could work. Is the man that we studied about today, or what else could we use there, class? Whom with an M. Okay? Whom or that we studied about today is my entire clause. What is that word describing, class, or that clause describing? Man. Number 11, God is a spirit, and they that worship him must worship him in spirit and in truth. Relatives there, class? That, what is my entire clause? That worship him. Okay? They must worship him in spirit and in truth is my dependent clause there, Doug. Okay, so make sure you're watching for that. Okay, what is that worship him describing? They. Number 12, a bibliophile is a person who loves books. What's my relative, class? Who? What's my entire clause? Who loves books? The entire clause is describing person. Good. Number 13, a man that hath friends must show himself friendly. What's my relative? That. What's my entire clause? That hath friends. What's that hath friends describing? Man. Number 14, Billy Budd, which was not published until 1924, was Herman Melville's last work. Relative, class? Which, what's my clause? Which was not published until 1924, describing what? Class? Billy Budd. Good. Number 15, the sackbut was a medieval instrument from which the modern trombone was developed. Relative, class? What do I put parentheses around? Good. Okay. And since that's part of a prepositional phrase, we might as well just include the word from. All right? And so from which the modern trombone was developed, what is that all describing? Instrument. Good. Okay. Homework for tonight is to do exercise C, putting parentheses around each adjective clause in the following selection. Draw an arrow to the noun or pronoun that the adjective clause modifies. Same thing that we're doing here, except now we're not circling the relatives, but we need to still look for the relatives. Okay. Within the sentence, they're not always going to be easily found, so make sure that you analyze each sentence there. Okay. All right, go ahead and look over at page 239. Page 239. Really quickly before we end, diagramming adjective clauses. Okay, so we just reviewed today, but we learned this yesterday. What are adjective clauses introduced by, class? Relatives. Okay, who, whom, whose, which, and that, or where, when, wherever. Okay, so those function as something within that clause. Okay, so let's look at how they function within the sentences. All right, look at your first example. God, who created the universe, also controls it. Okay, class, what's my phrase there, or my clause there? Who created the universe? Who is that talking about? God. Notice how that's an adjective phrase describing God. Okay, so within the phrase, within the dependent clause, okay, what's my subject and my verb? Who and created. What did he create? The universe. Okay. So notice the second part of that diagram. Who created the universe? I still diagram my subject and my verbs on my normal lines. What's my main subject and my main verb outside of the clause? God controls. Okay. What does God control? It. What is it? Good. A D-O. Okay. So now I have my main subject, my main verb. Now I have a clause to diagram. Who is my subject? Created. And because the relative who describes God, you draw a dotted line to connect them. Okay, that's why there's that dotted line there. Okay, everybody see that? So who is describing what, class? Who is describing God? That's why you see that dotted line right there. Okay, that's why it's connected, because the word who is describing God. But within that clause, it's functioning as the sentence. Okay? Look at the second example. That is a battle about which much has been written. Okay? So notice there, what's the word about, class? What's the word about? It is a preposition, so that's why, if you guys notice, the preposition goes underneath. Okay? Kind of like how we diagram prepositional phrases there. All right? But the word which is functioning as the OP. So notice how they have the word which on the OP line. Everybody looking at your book, okay? The which is on the object of the prepositional line. But still, it's connected to the word that it's talking about. You guys see that? Okay, so about which is describing what word, class? Battle. Okay, Doug, do you see that? Okay, the about which is my prepositional phrase there, but it is describing battle. But still, what's my subject and my verb within the dependent clause? Class, what's my verb? Okay, not much. Has been written is my verb. Who or what has been written, class? Much. Okay, so it's connected from the dependent clause to the independent clause by that dotted line from the word that it's describing. Okay? Look at your next example. A Chopin Nocturne was the first piece that he played. Class, what's my dependent clause? Isaac? Make sure you're paying attention, okay? Everybody paying attention. Class, what is my dependent clause? That he played, okay? Outside of the clause, my subject and my verb. Nocturne was, okay? Nocturne was what? Piece. Okay, what kind of word is that? What is that being used as? A PN. Okay, so that's my main subject and my main verb. So now that I have my clause there, that he played, what is that he played describing? Piece. Okay, so within that clause, what's my subject and my verb? Within the dependent clause, he played. Okay, he played who or what? That. Notice in that clause, that is functioning as the direct object. But because it's an adjective clause, it's connected to the word that it's describing. Okay? You guys see that there? So what word is it connected to, class? Peace. That's where we draw the dotted line. That to peace. Okay? Look at your next example. A hemophiliac is one whose blood does not clot properly. Okay? What is my dependent clause there, class? Whose blood does not clot properly. What is that clause describing? One. Okay? So notice, don't even think about a hemophiliac is one. Okay? We're looking at whose blood does not clot properly. Okay? Within that clause, what's my subject and my verb? Blood does clot. Okay, and what is whose? It's describing blood. It's saying whose blood? Whose blood, right? It's an adjective, so that's why it's underneath the word blood. But because it's my relative introducing my adjective clause, it's connected to the word one. You guys see that? Okay, so that's exactly what we're doing here. Okay, we'll practice diagrams tomorrow. So just kind of an intro to that, but homework for tonight, no grammar homework for tonight. Actually, grammar homework is that exercise B, page 237. Nothing for literature, roots, prefixes, and suffixes twice. All right? Thank you for holding on. You guys are dismissed.
All right, welcome to geometry. We're going to get started. We're on page 207. Page 207, 4.8, proving lines proportional. By theorem 57 and 59, when either of the conditions for similarity of polygons is true for two triangles, the other condition follows as a necessary consequence. Similar triangles are the usual means of proving lines are proportional. The steps are as follows. Select two triangles, each having two of the given lines. Prove that the two triangles are similar. Derive the proportion since corresponding sides of similar triangles are proportional, CSSTP. And then use alternation and inversion if necessary. In step one, it will often be helpful to write the required proportion as a fractional equation and assume that the two lines in each fraction are the corresponding sides in the two triangles. Distance learners, I'll be right back. All right, back to this. In step one, it will often be helpful to write the required proportion as a fractional equation and assume that the two lines in each fraction are corresponding sides in the two triangles. Then the lines in the two numerators will be the sides of the one triangle, and the three distinct letters used to represent these lines will be the vertices of that triangle. Use the same format for the lines in the two denominators. These triangles may be represented as I and double I, and the angles opposite the corresponding sides as 1 and 1 prime, 2 and 2 prime, etc. It becomes evident at once what pairs of angles must be proved equal to make I similar to double I. If the third pair of angles are identical, then it is necessary to prove only one other pair of angles equal. It is sometimes necessary to draw lines between points to form the triangles indicated by the three letters which are to form its vertices. Let's look at the following example. If my keyboard will ever work today, that would be amazing. All right, whatever. Given, triangle ABC is an inscribed triangle and CE bisects angle ACB. Again, let's make sure we're not talking. We are to prove, ladies, seriously, zip it. No. We are to prove that AD is to EB as CD is to CB. And so let's go through and work this out. Okay, we have the following proof. We have our given. We know that angle 1 must equal angle 1 prime because of definition of angle bisector. Angle 2 must equal angle 2 prime because angles inscribed in the same segment or equal segments are equal. You're going to have to pull back information you've learned in chapters 2 and chapters 3 to get this to work. Okay? Anything about circles is fair game. Anything about triangles is fair game. Okay? Because that's how proofs work. They just keep building. And there's a reason why I tell you guys about the back of the book. All right, so we've proven two angles equal, so therefore by angle, we have two similar triangles. Again, we represent them with Roman numerals I and double I. And then that means, since we have corresponding sides of similar triangles, they must be proportional, and we just list our proved line. All right? Does that make sense? A few additional things. First of all, to prove that the product of two lines equals the product of two other lines, use AD equals BC, which gives A over B equals C over D. Then proceed in the steps outlined in the section to take the product of the means and the extremes of the proportion derived in step 3. To prove that four lines are proportional when the lines are not found in similar triangles, find a third ratio equal to each of the two given ratios. Okay, you may have to create a third triangle, prove them both similar to that triangle. Okay, that may be what's necessary. Finally, to prove that two angles are equal based on similar triangles, use corresponding angles of similar triangles are equal, also spelled cast, which just is another way to express the definition of similar polygons applied to triangles. All right, does that make sense? Homework tonight is exercises 4.8, numbers 4, 5, and 10. You also have Tuesday night's homework to finish and complete and submit by tomorrow. I'm going to hand out a piece of paper, so just give it a second. So you have Tuesday's work to complete. Tonight's homework is a bit different. I'm giving you guys fill-in-the-blank proofs. If you're a distance learner, that has been provided to you on Google Classroom. If you can't print, just write the answers on separate paper or type it in a Google Doc and submit it that way. I don't care, just as long as the answers get to me, okay? But the PDF is on Google Classroom. In class, you'll be handed the paper for you guys to fill out. There's no name blank, so please write your name on the paper, okay? This was designed to be a completely digital assignment, and then I'm not using Edmodo, so I can't use Word online anymore. So, all right, make sense? Cool. Distance learners, I'll see you guys later. Again, make sure you guys finish Tuesday night's homework. I did update it this morning because apparently I gave information about the wrong problem. Ladies, you are being unbelievably rude right now. I mean, absolutely unbelievably rude. Again, remember, Tuesday night's homework due tomorrow. I just updated the information today because I had information about the wrong second problem on there. Okay? This homework also due tomorrow. However, fill in the blank should probably only take you about 5 minutes. All right, distance learners, I'll see you guys later.
although I'm not ready. Okay. Okay, lesson that we didn't do yesterday. Welcome back to science, everybody. Lesson we didn't do yesterday, we're doing today. On Monday, I told you that you would have a, gentlemen, you would have a elements quiz today. Postponing that till Monday. So make sure that you are memorizing all of those elements on page 305, right? No, let me see. Yeah, 308, 309. Okay. All of those are your common elements that are used a lot in the book, your subject, just in general use. So those are need to be memorized, all of them. So plan on a quiz over all of them on Monday, along with taking a couple other quizzes that were scheduled for today. Okay, 25 and 26, I believe, is what they were. Okay, so we'll just postpone all those quizzes till Monday. Quiz 25, 26, and your element, all of your element quiz. Okay. One of your quizzes, 26, I think, is 25 or 26 is an element quiz, but we're going to double up on your element quiz, or maybe we'll cancel one of those. That's what we'll do. Somebody look at your review sheets for quizzes. I don't have them in front of me right now. Which one is the element? Is that 26? Okay. We will cancel 26 because that's not covering all of the elements. So quiz 26 is no longer going to be, but you will have an actual quiz over all of those elements on page 308 and 309 in place of 26. Okay? And both, so there's no confusion. On Monday, and this is because volleyball's out tomorrow. On Monday, we have quiz 25 and all of your elements from 308 and 309. Okay, that's quiz on Monday also. Come in quietly, have a seat right now. Hey, sit down, I'm talking. One more time. On Monday, you have quiz 25 and your element quiz from pages 308 to 309. Add a piece of paper. This is for a couple days ago. Actually, it's for this one. See what you come up with here. Okay? Ready? Here's your reading quiz. No talking, please. I still hear some talking. Please stop. Amethyst, slide over to your desk, please. Okay. Okay, is everybody done? Anybody not? Okay, here's your answers. Looks like 5 is the only false. Yeah. Okay, shh. Jaden? Derek? You said 6? Okay. Isaac? Andrew? Amethyst? Austin? Maya? Doug? Sophia? Yuvia? Lena? Adrian? 7? 6? Gabby? Jesse? Quiet guys. Ricky? 6? Avery? Elijah? Okay. Okay, let's see what we can get done here. See if we can get through lesson 130 today, okay? Okay. A little bit of review first. John Dalton proposed that all matter consists of tiny particles called what? Atoms. Good. What is the dense central core of an atom called? Huh? Oh, come on. Center part of an atom? What? Yeah, the nucleus. Okay. I didn't hear what you said, Elijah. What are the two types of nucleons that are found in the nucleus? The protons and neutrons. Okay. All we've done is change the wording a little bit. We call them nucleons now. Okay. Same thing we've been studying or have studied over the years. What does the number of protons in the nucleus determine about the atom? Atomic number, okay? Which deals with its charge, yeah. What subatomic particle is electrically neutral with no electrical charge? The neutron. What are atoms that are the same element, okay, same atomic number, but have different numbers of neutrons called? Shh, guys. Derek, Doug. Called isotopes. What are protons and neutrons composed of? Quarks. What is the subatomic particle outside the nucleus and carries a negative electric charge? Outside the nucleus. Huh? Nope. Well, you're getting there, but not right now. What's the main thing called? Amethyst. I asked you to move to your table. That's twice now. Okay. Called electrons. What are any of the concentric layers surrounding the nucleus in which the electrons can be found? What are those called? Electron shells. Isaac. What is an atom that has an electric charge because of losing or gaining electrons called? called ions. Good. Okay, let's talk about the atomic measurements now. So the mass number, that's just the atom's mass number. The number of protons and neutrons in the nucleus. Okay? Typical, for example, like a typical aluminum atom is 27. That means it has 13 protons plus 14 neutrons. Okay? And as you can see on the diagram, shh, Adrian, guys going to start putting checks down now. Give enough verbals. As you can see on this little chart, the aluminum, its element number or symbol is Al. Atomic number 13. Atomic mass is 27. So when you start putting those together and looking at that, you start doing a division. Protons is 13. Neutrons is 14 because that makes up the atomic mass, the protons and neutrons. Now look at what the electrons are. Electrons are 13. Generally, and I'm saying this generally, most likely, that you're going to have the same amount of protons as as electrons, although that can change when atoms gain or lose an electron. Okay, but generally by numbers, they're generally the same number. The mass numbers are whole numbers because they represent the numbers of whole particles within the atom or outside. Now, most of an atom's mass comes from the protons and neutrons. So therefore the mass number is an approximate measure of the atom's mass. Why, Ricky, is it an approximate number? Pay attention. Isaac, why is it an approximate number? Pay attention. Adrian, why is it an approximate number? Why is it an approximate number, not an actual number? What? It has what? Say it again. Answer me properly. Okay, pay attention, guys. It's because we can't actually study the insides totally. They're going to be gaining. They're going to be losing. Amethyst, you just got to check for not being in your seat, for being out of your seat, one of the two. Go sit down in your seat and stay there, please. Okay, because they're losing and gaining those electrons, okay, that's why in these cases that they're approximate numbers. Okay? If the numbers are matching up, the massive numbers, then they're going to change to somewhat sometimes too. So that's why. So because atoms are so small, the masses of atoms are usually measured in their atomic mass units. Okay? And again, because they're so small, that's why they are approximate numbers. On 2C, the mass of an atom in atomic mass units is approximately equal to the mass number. Okay, approximately equal to. Again, there's a variance in there. But we go on these numbers because it gives us a sense of normality, I guess, would be a term to be used, or that could be used. Okay. Now, So it brings us to the topic of an average on number 3A, average masses. Average atomic mass is the average mass of all the natural isotopes of an element calculated according to the isotope relative abundance. Okay, so look at this example. The element boron has two isotopes, B10, which has a mass of 10.013 average mass units, or 19.8% abundance in it. It also has B11, mass of 11.009 AMUs, or 80.2% abundance. So you calculate the average, and we all know how to average things out. We add the two together and divide by 2, because there's 2 units. So in this case, the average atomic mass is 10.81 AMU. Okay? A lot of numbers, yes. Science is math. Okay? And the more higher up science you get, the more math you're going to get. Okay? Now, so when chemists speak of atomic masses of an electron, or an element, excuse me, they're usually meaning the average atomic mass, which is measured in those atomic mass units. Okay? This is a general term that chemists will talk about, will deal with. Okay? And so they know what each one's referring to when they're talking. So if a chemist means the number of protons and neutrons in an atom, they use the term mass number. Saves them time, saves them, etc. They don't have to go and say, oh, well, let's see. There's 13 protons, there's 14 neutrons. Okay, so that's the atomic mass. Well, they just say atomic mass of etc. So they take 27, then one's got to be 13, one's got to be 14. Okay? And they can determine that based upon the electrons also. So if you look at this, the average, this chart that's on table 13.3, page 312 of your books, you have the elements, hydrogen, helium, carbon, aluminum, and with that you have their atomic mass, or their symbol U. Hydrogen has an average atomic mass of 1.008. Helium has 4.003. Carbon, 12.01. Aluminum, 26.98. Iron of 35.85. Bromine, 79.90. Xenon, 131.3. Gold of 197.0. Lead of 207.2. And uranium of 238.0. Okay, so just giving you some examples there of the various elements and their differences of average atomic masses. With talking about atomic mass measurements, we deal with atomic or quantum mechanics. In the quantum mechanics, we talk about atomic models. These are just illustrations that show the structure of atoms that describe that structural mathematically. Okay? The early models of an atom, table 13.6, page 313, says Dalton in 1803 looked at the atomic structure as just a hard sphere. Thomson in 1898 looked at it as plum pudding. Okay? Rutherford in 1911 looked at it as a planetary situation where things are floating all over outside the nucleus. Okay? So if you look at the diagram, the hard sphere, the one on the left is Dalton. The plum pudding. See how it looks like kind of like a pie situation, or pudding where you've got the outside crust going on, and then you got the little indent, little circles inside, and whatever the X is there, indicating. But it looks like, in his view, like plum pudding. Then the Rutherford, which is the third one, just looks like a bunch of dots outside that are floating or rotating all over the nucleus, like our solar system would be. The planetary idea of that. Okay? Those were the early models of the atoms. Well, this quantum theory was developed by this gentleman, Max Planck. It was developed in the early 1900s. His theory was this: tiny particles, like electrons, do not absorb or release energy in a smooth flow. Okay? They do not absorb or release. It's a magnetic type of situation where things are jolted out, jolted in, brought in, etc. Yes. Okay. Now, energy with electrons is always absorbed or released in a discrete packet. That packet is called the quantum. Okay? And that's where his theory is coming off of. This little packet of energy that's being absorbed or released by the atom. Now, if you take the quantum theory, put it into an example, it'd be like this. A tennis ball on a set of stairs. On its own, the tennis ball cannot be between the stairs. Okay? The tennis ball has to either be sitting on the top stair or it has to be sitting on the bottom stair. It cannot be in between. Okay? And that's just logic. Guys, put your phones away. Or otherwise they're mine for the rest of the day. A tennis ball or a ball cannot be in between the stairs. Okay? This dog right here is wanting someone to move the ball for him so he can go chase it. Okay? Or lift it up to him or whatever. But the ball is sitting on the stair. It's not in the rise of the stair. Okay? It can't be in between. It's either going to be on the one below the dog or the one that's on the with the dog. Okay? Okay? So, that's the quantum theory idea. Well, with electrons, they move in and out of the electron levels. Okay? Can we stop talking over here, 10th grade? So electrons change their shells when they gain or they lose energy. So when an electron gains a quantum of energy, it moves farther away from the nucleus. When it loses a quantum, it moves closer to it. Okay? So it's losing the energy, which means the minus part, it's coming back home to the nucleus. Gaining, you're plussing, so it's going further away in perspective. So when electrons change energy levels, they are said to have done a quantum jump. So when you that's two, Amethyst. Avery, one. Doug's got one. Derek's got one also. So, when you hear this in your sci-fi movies, Star Trek, Star Wars, okay, talking about quantum jumps, okay, they're taking this aspect of electrons moving, okay, they're not moving their ship and everything that way, but they are using the electrons to make this quantum jump in the system. There you go. That's the idea, yeah. Okay? Yes. Quantum jump? Yeah, it's possible. Because the electrons are doing the jump. Theoretically, yeah. Yes. 10th grade. No one's given permission to open discussion. Okay? Yeah. Basically. Adrian? Yes. Okay. So, quantum mechanics. We talked about quantum mechanics deals with atomic structures. Okay? Atomic models. Let's start off with the Bohr model. In 1913, Niels Bohr, a German physicist, proposed this Bohr model that looks just like this in the picture. The Bohr model is your most familiar model of the atoms. It pictures the nucleus surrounded by all the electrons that move in a circular orbit or a specific energy level. Doug, Derek, bring the phone up here if that's what you guys are watching. What are you guys looking at? You both are staring at something there. So you see in this case it has two energy levels, two energy shells. Each shell, in this case, the first one has two, which is always the general, and then it adds electrons on the outside. Okay, but that's your Bohr. It's got the nucleus and then the circles of electrons, energy levels outside of it. You have also the wave mechanical model. This was developed in the mid-1920s. Physicists discovered that electrons have characteristics of both particles and waves. So they put this all together. The electrons act like particles when they interact with other matter, and then they also act like waves when they travel around. So to show the two differences here, the Bohr model is on the left, the wave mechanical model is on the right. So look how the atoms, the wave patterns, the electron shells, if we can call it that in this case, are moving an in and out pattern like a wave does. Okay? That's your wave mechanical model. In 1926, Erwin Schrödinger, Australian physicist, described electrons as wave around the nucleus, and he's the one that developed this wave mechanical model. So, by definition, a wave mechanical model is just, or what's also called the quantum mechanical model, is just, Adrian, you just got to check. Okay? That's your second. It's a model that describes electrons as waves around the nucleus. I understand you needed a Kleenex, but you could have asked first. Okay? Actually, Adrian, that's your first, sorry. Okay. Now, the third is your Heisenberg uncertainty principle, or dealing with all this. In 1927, Werner Heisenberg proposed the Heisenberg uncertainty principle, okay, which states that it is impossible to measure both the position and the velocity of an electron with certainty, which goes back to our original thought of why you have the average going on, and it is because of the uncertainty between or inside of everything. Okay? Then we have what's called the electron clouds. Okay? In 1928, Max Born used the Heisenberg uncertainty principle to modify the wave mechanical model, and he also developed the electron cloud model. Okay? So in this case, we've got our nucleus, we've got our, in essence, our proton here, but all of this bouncing around the electron clouds was all that blue stuff that you see on this picture. Okay? Nothing is stable in a cloud. All of these blue dots on this picture are your average distances of electrons from your protons. Okay? You have the ground state of it and you have the excited state of it. But they're all bouncing around like in this virtual reality type perspective. Ricky? Girls in the back, stop, please. Oh, really? No, I've not seen it. Be neat to see. So, by definition, here it is. Electron cloud model. It's a model of the atom that interprets the mathematical equation. Okay? Dealing with your math aspect here. Of the wave mechanical model as representing the probability of finding an electron at a given point. Okay? Now, how difficult is that going to be? It's probably going to be pretty difficult because of the cloud aspect in there. Each orbit, okay, so in this, electrons that do not have definite orbits around the nucleus, but electrons move unpredictably inside the region, are called they're called orbitals. Each orbital can hold up to 2 electrons. Each electron shell, which is your energy levels, is made up of one or more orbitals. So the way to visualize electron cloud models is by using dots indicating the probability, okay, we have to include those words, of each electron. Girls, you just got another check. One of you just got a demerit. Okay? I've asked you several times to stop, and you don't. Okay? So do it now. Amethyst, that's enough. By using your probability contour, which is a three-dimensional surface that follows the shape of the electron cloud, it includes your 90% to 95% of the dots. Okay? So it's just using those dots out there as a probability of where those electrons could be. So all of this quantum theory, we've got to come up with a precise number here. And that's what we call the quantum number. Quantum number is just a set of numbers that mathematically represents the overall motion of the electrons. Okay? Electron shell. Each electron shell is divided into one or more subshells. Okay? One more subshells floating around each of those particles. Each of the subshells is assigned a different letter. Okay? The second quantum number identifies the subshell. Those orbitals in the subshell have characteristic shapes. Some are like spheres, some are dumbbells, some are clover leaves. Okay? In those orbitals in a subshell, they have different orientations in space. Some are horizontal, some are vertical, some are diagonal. Okay? Like your third row there. And then you have your third quantum number that determines the specific orientation and thus the specific orbital within the subshell. Your fourth identifies the spin of the electron. Which brings us to the Pauli exclusion principle. It says that no two electrons in an atom can have the same four quantum numbers. And that goes back to the various shapes, the various spins of those numbers, of those subshells. Okay? Okay. Your homework tonight is section review 13.2. Once again, these quizzes, 25, 26 is no, 25 is Monday, 26 is not, but you have an electron or your element quiz on Monday. Okay? You are dismissed. Okay, DL, sorry. That's it for class today.
All right, welcome to Algebra 1. Whoops, my camera is, you know what, it's fine. All right, quiet down. We're on 7.8, factoring by grouping. Factoring by grouping. All right, this is one of those concepts that Becca extremely over-explained, so I'm just going to kind of ignore the textbook explanation. It's not that they're wrong, it's just too many words. Okay, I'm going to give you guys the TLDR, because not even I want to read all that. Yes, the TLDR. Oh, come on. Come on, y'all know what that means. Too long didn't read. It's the summary you give for people who don't want to read the whole thing. Okay. Example A. All right, listen up. There will be no more communication while I'm teaching. Do I make myself abundantly clear?
Yes, Tom. Yeah.
Are you doing your bodybuilder pose?
Now contract.
Mr. S, do
Contract your
bodybuilder
biceps.
pose.
Contract your bicep.
What did I just say, Rick? Shh. Out. You first. Go. He will meet you out there. Go. Go. Okay. All right. So, step 1 of this. Okay, after you're done mentally flipping out because there's now 4 terms instead of 3. Okay?
What the?
There it is. All right, anyway. Okay, step 1. I don't know if y'all can handle this. Y'all ready?
Hit me with the best shot, Mr. S. Please don't.
Give you it.
Put parentheses here and here.
That's your answer.
No. That's step 1, though. All right, Adrian, settle down. All right, too much. Ladies, make sure we're not talking. If we can't do that, Amethyst, you can go to lunch. All right. So, real quick, then what we do is we factor out the greatest common factor in each group. That's why it's called factoring by grouping. We're doing groups at first. Ha! Okay, we factored it, we're grouping it. Parentheses. Good? All right, so let's factor out the common factor. What's in common in this first set of parentheses? X squared. What's left?
X plus 2.
Thank you. One person who, knows how to factor. All right. Does that make sense? Yes, no, maybe. We're not done, to be clear. I'm pausing. What's in common in the second set of parentheses? What's left?
X plus 10. X plus 2.
X plus 2. Okay, let's go back through and talk about it. Make sure you're not talking. Put it down. You're not eating in my class. Put it away. Lunch was 2 classes ago. Eat then. Or during your 10-minute break. Classes before you wish they had 10 minutes. Chair on the floor. Act like you're in class for once. Okay. So, here's what we did. In x cubed and 2x squared, there is an x squared inside it. Right? Okay? So when we take x cubed divided by x squared, we get x. When we take 2x squared and divide it by x squared, we get 2. That's why that's what's left. Cool? Okay. Next section, we divided both sides by 5. Or not both sides, but both pieces by 5. That basically is what we did. And pulled out that common factor. Okay? Make sense? Okay. All right. Now, notice we have a common factor in parentheses now. So we can factor that out. So we have x plus 2 in common. What's left in my first term if I pull out x plus 2? X squared. What's left in my second term if x plus 2 is removed? Plus 5. Adrian, please answer in English. Okay. That's it. We're done.
Wait, we're not doing the box thing?
Nope. Now, pay attention and listen to something. Stop interrupting me. All of you. Now, Adrian, chair on the floor. Again, act like you're in class. I don't understand. Thank you. Notice that we started with 4 terms, not 3. This only works if you have 4 terms. If we have 3 terms, you use the box or one of the shortcuts.
If you have more than 4 terms, it's not
Good luck. All right, you won't get that kind of problem. Okay, we're not teaching all that. All right, yes. It got divided by x squared. Okay, you guys, I don't understand how else to word this because we've been doing it all chapter. Okay, so please pay attention to this. Okay? This right here is this times this. We split it up. That's all that happened. It didn't disappear. It didn't go away. It didn't transform. It got split. It's still there. It just has different looks. It's like getting a haircut. You're still the same person. Make sense? Yes?
How did you get the x squared again?
For the love. Again, we're just doing 7.2 again. We've been doing 7.2 the whole chapter 7. You have something in common, you pull it out. X squared is in both x cubed and 2x squared. It exists in both places, so it's in common. It's greatest common factor. So that's where it comes from. I have no other way to word it other than it's the greatest common factor, so we're pulling it out. Like, seriously, guys, all stinking chapter. No, because, no, don't start. Because you're part of the other group of I get annoyed with because you think you don't need to pay attention, so you don't. And then you annoy everyone else around you. Okay, this is where I get annoyed. Are we good? Do we all see it now? Thank you. Example B. Same idea, we're going to do the exact same thing. However, there's a catch on this one, so pay attention, it's subtle. Okay, first of all, that. Second of all, here, and we're going to put a plus sign in the middle. Okay, it has to be a plus sign in the middle, so you have to keep the negative with the number. The only reason why we didn't do that on the last one is because it was all plus signs, it didn't matter. Does that make sense?
Also, it's like when we were doing the box, but like when you have to find the factors.
Kinda, yeah. Okay, sign stays with the number, so we have a little itty bitty plus sign inserted right there. Cool? Okay, that's the only catch, is that if there's a negative right where you're going to divide it up, you have to put a plus sign in between the parentheses because we're not multiplying. You cannot imply multiplication. We are adding. Okay? So, what is in common with both x cubed and x squared? X squared. What's left from x cubed once I divide? What's left from x squared once I divide?
1.
1. Keep in mind, I have to leave it somewhere to multiply with again. Okay? It's not that, we need a 1. It's we need to be able to reintroduce x squared when we multiply through. Does that make sense? Okay? So we're going to have a plus sign. Okay? What's in common here?
3.
A negative 3. Okay? Now, you were correct. This would still work, but we don't like negative x's. Okay? That sounded like a whole different sentence. All right, anyway. If in a non-math context. Negative x, moving on. Nothing. It was a horrible joke. All right, what's left after I divide the first term by negative 3? Positive x. What's left of the second term? 1. Does that make sense? Because I have a plus negative. It just looks dumb. That's the only reason. Okay, so notice how x plus 1 is now a common factor of the whole thing. So what's left in my first term after I remove it? What's left in my second term? Negative 3. I can simply write it this way. Okay, now you'll notice I have a high possibility for a difference of squares here, so pay attention for that. This is not, because 3 is not a square. Like if you have x squared minus 4, you can make it x plus 2, x minus 2. 7.3, man.
Okay, yeah,
Or 7.4, somewhere in there.
you just went all M&M on the road. That was so fast.
Anyway, I'm just saying make sure you can't keep factoring once this is done. That's all I'm saying. All right, we good? Cool. Example C. Okay, so we're going to separate it out. There was a negative, so I'm going to insert a plus sign. We good? Okay. What's in common in my first group? X squared. What's left of my first term?
X minus 3.
Cool. That's what's left. Okay. Plus, what's in common here?
4.
Okay, we're going to pull out a negative 4 because we want x to be positive. We're trying to get two parenthesis sets that match. That's why. So if x is positive, it gives us better odds. Okay, so we're going to pull out a negative 4. What's left here?
3. Oh, x minus 3.
Yeah, because negative 4 times x is negative 4x. Negative 4 times negative 3 is positive 12. Do you guys see that? Okay, that's what we're doing. So x minus 3 is in common. Pull that out. First term is simply x squared. Second term is negative 4. This is what I was talking about. You might still be able to factor. Okay? X minus 3 just comes down for the ride. Okay? How do I factor out the difference of squares? No. What's the square root of x squared? What's the square root of 4? So I have x plus 2, x minus 2. That thing.
Oh, so the bottom one's the answer.
Yes.
So you could still
You only do that if you can. It's not something you have will do every time, obviously, because we didn't do it before. Okay.
you had to have only 4 terms.
At the beginning. The first statement have 4 terms. We're good. So we
I
get.
thought you meant like for your answer you had.
No. That has nothing to do with it.
Oh.
You'd get to this step initially, and then you double check that you can't do anything else.
Oh.
Cool.
What if some people
Whoops.
have
Sorry.
like
Yes.
No, so your whole answer was all 3 of them?
Is the bottom one? Yes. This is my answer.
How do you check this?
Whoops. You remultiply it through. FOIL it. Does that make sense? Okay, checks are shown in the book. I just don't bother showing checks in class because some people think they have, that's part of the answer. No. Yes?
So just everything correctly. If you could split it up, you split it up.
Yes. Yeah, if you can keep factoring, you keep factoring. That's always the rule with factoring. That's why the directions always say factor completely. You might have to combine more than one type of factoring. Okay. Example D. All right, let's try this one. First of all, do check that there's nothing in common all the way across, because if there is, that makes things easier and is required. There isn't in this case. I'm just saying make sure you check for that. That's always rule 1 of factoring. Make sure there's nothing in common all the way down, okay? All right, so let's separate into our groups. We have a plus sign in our place of division, so I don't have to worry about that. What's in common here?
X squared.
What else?
2.
4.
Oh, yeah.
Yeah, a 2 is in common, but 4 is the most in common. All right, what's left of the first term? Good. What's left of the second term? Negative 5 only.
If you back it up, 4x2.
Does that make sense? Okay. What's in common in our second group? Nothing. But notice it matches identically what we have here. Okay. So 2x minus 5 just gets copied down. That is our group. That is factored. Okay. If there's nothing I can pull out, what do I put? A 1. You don't necessarily have to write that there. It's just easier for showing what I'm doing. Okay. So I have 2x minus 5 in common. I have 4x squared left plus 1. If you didn't write a 1 here, you have to write it here, because we need somewhere for it to remultiply with. Does that make sense? I don't have a difference, so this cannot be factored anymore. Does that make sense?
Wait, so why do you put the 1 again?
Because otherwise, when I would try to multiply it back through, I would lose part of my answer. If you don't leave a 1 for you to multiply back with. So, for example, let's...
Since we have 4x squared, you have to have something to multiply by.
Yeah, because we're factoring out this 2x minus 5. So if I don't write a plus 1 here, I got 4x squared times 2x minus 5. I only have this first half of the answer as a result.
So you're just doing it because you need both sides of the answer.
Yes, because I need to have something to multiply with to get something there.
Okay, so you just put a red bubble, right?
No, we just put 1 because we can multiply with it without changing anything.
Yes, that's
It allows us to copy and paste. That's what 1 lets us do in multiplication. Hold on, guys, one person at a time. What?
Why did you say that it's done through the 2 and a 4?
I don't understand the question. I'm sorry.
No, why do you just leave it like that? I thought you could do the 2 and the 4.
What do you mean the 2 and the 4?
Oh, never mind.
Okay, I didn't understand the question. Sorry. You good? Okay. Yes. Yeah. You just write whatever's left after you pull out the 2x minus 5.
So after
after those are common, you just carry whatever's on the outside down.
Yep. It just gets brought down into its own set. All right, we good? Okay, there is one chance for it to go wrong. So let me explain how this works. It's okay. It's a very easy fix. Okay. So this next one is going to look impossible when I first do it. Okay. And then I'm going to show you guys how we fix that. Okay. Does that make sense? So this is going to fail. I'm letting you know that off the top of your head. So I just want you guys to see what happens though.
Question. All right. How do we know that it's already failed?
I happen to know ahead of time. I'm going to show you the symptom of it failing, and then I'm going to show you how to fix it.
We actually have to do the problem to know that it'll fail.
You won't know they'll fail at the beginning. I know this will fail because it's purposely an example of one that fails. So normally, I'm going to show you what it's going to look like and how to fix it. So, all right. So first of all, I'm going to separate out into groups. Insert my plus sign. In common here, all I have is a 2 plus, and all I have in common here is a negative x. This is b plus 8a. I have nothing in common. I have no way to get anything in common. Do you see that?
Yeah.
I can't manipulate it by factoring out an extra negative or something like that. Okay? But they're not even remotely like terms. There's no way for me to get x cubed on the other side. There's nothing here. Okay. Now, let me show you how to fix it. It's real easy. Okay? When you get to that point and you realize there's no continuing, erase and do this. Okay? I'm going to rewrite the problem and flip the middle terms. It just means I was given it in the wrong order.
Why do we flip the little term?
Watch. Okay? I seriously mean that. It's just, if it doesn't work the first time, try it with the middle two terms flipped. If it doesn't work then you can't factor it. Does that make sense? Prime. Okay. All right, so here, let's go through and group this again. Okay? So notice here, now I have a common x, and I have 4x squared minus b. Yes? Okay. Notice here, I can factor out a 2a, and I'm purposely leaving it positive. You'll see why in a minute. Okay? You would notice, if you ever get it where subtraction is backward, it just means you need to factor out a negative or not factor out a negative. Does that make sense?
Wait, so
Bear with me for a second. Okay. Notice what that's going to leave me. It's going to leave me negative b plus 4x. Hold up. Something's wrong. I feel like I did a typo in the original problem. Can I see your book?
The negative 4x is squared. I mean, the 4x is squared.
Oh, it's 4x squared, not 4x cubed. Yeah, that'll do it. Rip. Okay, first of all, make sure you write down the problem correctly. That's actually step one. Let me fix that real quick. That explains why it wasn't working. Okay, that one was prime because we couldn't get anything similar. But let's show you guys what happens. Okay, spoiler: first way still fails. I'm gonna flip the numbers now. Okay, so rip. Thank you. Thank you. I'm here all week. Okay. So we're going to have 4x squared minus bx negative 2ab plus 8x is my grouping. Okay? Right. Thank you. Okay. It never fails. Once there's one typo in a problem, it's just going to happen the rest of the time. All right. So factor out x. We get 4x minus b. I'm going to factor out a 2a, which is going to leave me with negative b plus 4x.
oh, you're factoring out positive because 8 is positive.
Cool. The entire reason why I kept this positive is because I saw that I wanted b negative.
Oh, never mind. I didn't get it. Why do you want B negative?
Because this set of parentheses is the exact same as this set of parentheses. It's just written wrong. So it's the same thing. So if you ever get like down to this, let's say I factored out a negative and I had b minus 4x. Anytime you see they're the exact same but your signs are backwards, you just need to either factor out a negative 1 or undo factoring out a negative 1. Does that make sense?
Yeah.
Okay. So that may come up occasionally.
Okay.
So I don't want to factor out a negative 1 in this case because I want b to be negative. Cool? Whoops, nope, I put that in the wrong spot. Why does undo not work in PowerPoint? Oh, I hate this so much. No. All right, cool. So now I have 4x minus b in both terms. The second one is just written funky. Does that make sense? Okay. So we have 4x minus b in this one, and so we leave x plus 2a. All right, so if it ever fails the first time, first of all, make sure you wrote the problem correctly. And then as long as you did that, then you just flip the middle terms and try again. Usually that will fix it. Does that make sense? Cool. That's the only real catch. Again, always check for a full common factor first. Then do grouping. If the first grouping fails, switch it to the second group. The first grouping rarely fails. Like, does that make sense? Like, it's rare that you have to flip the middle terms, but just in case you ever get stuck, that's all you have to do. Yep.
So are there any of those in the homework?
Potentially. Probably. Cool. Practice 7.8 blue. Also, real quick. Yes, you guys have a quiz tomorrow. Okay. Now, this is going to look evil, but just keep in mind, everything in this section, we could potentially pull stuff from anywhere. Does that make sense? So your quiz is quiz 24, which is over 7.2 to 7.8. But again, that's just because factoring builds on itself like that. Does that make sense? So it looks horrible, but again, we're factoring out common factors, which is 7.2. We're possibly having the difference of squares. You all follow me?
No.
In other words, Chapter 7 keeps building on itself, and if you all can't handle going from section to section without forgetting the previous section, you're going to struggle. Because that's how factoring requires that cumulative knowledge. Okay? So that's the reality of it.
So then why did the last quiz we only had like 7.5?
This is also a review. Oh, wait. Hold on. Hold the phone. Shh. Can I just see your book? That'll be faster. Thank you. I'm sorry, that's why I don't have the quiz on the slide yet. It's not tomorrow. I need to fix that in my lesson plans. I forgot. I want to do this quiz after next lesson where we put everything together. Okay? So there is no quiz tomorrow. I am sorry. Tomorrow we will talk about general factoring strategies. So if you're not going to be here, you need to go on stream and look at how to do it. All right? Good? It won't be Monday. I'm not that pure. I'll let you guys know tomorrow what day. Well, I have done it, and I may have to. But I am not anticipating it to be Monday. That is not a promise. That is not a guarantee.
So I might be here tomorrow and Monday.
Okay. All right. See you guys.